Hello friends, welcome back to this series of standard template libraries, and today we are going to discuss about the allocators, the unary function objects and the binary function objects. How to create unary function objects, how to create binary function objects, how to create your own and how to use them. Okay, so all these three things we are going to discuss. As you know that we are not discussing as of now about the core concepts of the STL. We have not even discussed about the containers or anything for that matter, because before that you must need to know about these things, what are allocators, unary function objects, predicates and all these things that we are discussing for past 3 to 4 videos. So in today's video we are going to discuss about the allocators first. So what are the allocators? When we talk about the allocators, then we need to take care of some scenarios. We need to understand some scenarios so that you can create your own classes and you can decide when to use the allocators and when not to use. You know that whenever we create an object, then the constructor of the class is called for that object. And the constructor has all the logic to construct the object. But it may be sometimes that the memory allocation for an object, or you can say the memory allocation and the initialization of the object, is necessary only one time. But in subsequent operations, it may be that you just need to allocate or deallocate the memory, but the original object need to be intact. It doesn't need to be called for the destructor. The object doesn't need to be destroyed, or you may not need to again construct the object, which means that only you have to deal with the memory. You don't have to deal with the construction of the objects. In that case, the allocators are very much useful. One such example is the vector. In case of vector, we will work more into the vectors when we will actually start the STL classes, actual concepts of the STL. But in a nutshell, I would like to tell you that vector is just like an array. It is dynamically allocated, right? Once you have allocated the memory and you have initialized the object for vector, after that, anything you do, and if that needs to allocate a memory or deallocate a memory, so all these allocation and deallocation of memories with the vector object doesn't need to construct or reconstruct the entire object again. So such kind of scenarios, allocators are very much useful, where you just need to deal with the extra memory allocation or you just need to deallocate the memory, right? So let's see how we can use the allocators, right? So let's see what we are doing with the allocators and how we can work with them. My dummy class, this is the name of the class which I am creating, and here I'm just going to write one constructor for this class and one destructor for this class. Okay, so that's it. And in that constructor I'm going to write like a message, the CTOR called, and in the destructor the DTOR called. All right, and here I'm going to use the allocator for the my dummy class, ALL. I have created this object of allocator class, and now I am just going to allocate the memory for three objects of type my dummy class. Okay, so here what I'm going to do, my dummy class pointer p is equal to ALL dot allocate for three objects, right? So it will allocate the memory for three objects and return the memory to this pointer. And after that, if I do all dot deallocate p, and how many blocks I need to remove? I need to remove all three blocks. So you can give like this. So here we are creating the object, but we are just allocating the memory for that object that is needed by this object. We are not calling the constructor or the destructor. Whenever we will use our class with allocator in this manner, then no constructor or destructor will be called during the creation and destruction of the object. Okay, so let's see. If my constructor or the destructor will be called, then these messages must have been printed, but these will not be printed, and that will prove that allocator only allocates the memory. You can see that no such message came like CTOR called or the DTOR called. So here only the memory was allocated, and here it was only deallocated. During the allocation, no constructor call, and during the deallocation of memory, no destructor call. So this proves that allocators are only useful for allocating the memory, and allocator keeps the task of memory allocation and construction or destruction of object separate. Memory allocation is separate, and construction or destruction of the object, that logic is separate. So to keep the logic of construction of an object and destruction of an object and the actual memory allocation for that object, if we want to keep them separate, then in that case we can use the allocators. Okay, so allocator for my dummy class and allocator for the constructor and destructor for this I have explained to you, and I hope you have got the point. If you want to see that how they are used in the vectors, that I will show you in the coming videos when I will discuss about the vectors. Okay, so let's move ahead to the next topic, and I hope you have got the point about the allocators. What are they and for what purpose they are used? So let's quickly move to the other topic, which is the unary function, and then we will see the binary functions. Okay, just like unary predicates, we have unary functions. But unary functions, they are not returning true or false only. They can return any type of value, any type of result. Okay, and similarly, the binary functions are there. The only difference between unary function and binary function is that unary function takes only one argument and returns the result of any type that you decide. And in case of binary functions, the function takes the functor, rather I should say functor. The functor takes two arguments and it returns the value of any other type. So let's see how we can create the unary function and the binary function of our own choice. Okay, so first I'm going to create our own unary function. So how I will write it? Before that, you need to just create a template. There will be two types. One will be the type of the argument, since we will pass only one argument. So there is only one class for argument one, and there will be other class for the result. Right? So there will be a type of result and there will be a type of argument. So I have written like this, and then I'm going to create a class, and the name of the class is get square, and I'm just going to inherit it from the standard unary function class. There is a standard unary function class provided to us, and the name of the class is unary function. This has already been provided by the standard template library. If you want to see how it looks like, just right click on it and go to the definition, and you will be able to see that this is the class, and the name of the class is xxtddef, and here you can see like there is a structure unary function, and for that we have argument types defined already, and this is the base class of any unary function that you want to write in your own application, right? So we are just using that unary function class, and what does it take? It takes argument 1 and a result. Okay, so now what we will do, here we are going to write a function public, and again this is a functor. This class will act like a functor, which means the object of this class will act like a function. Okay, so what we need to do, we just need to provide the return type result, and what we need to do then, we just need to implement this operator. And what is the argument? Argument 1 arg1. All right, so it is taking argument 1 and result is type result, right? So here we are just going to provide the square of the number which will be passed here. So it will be return arg1 into arg2, sorry, arg1. right? So we are multiplying this number by itself to get the result, to get the square. That's it. This is our unary functor. This is our unary function. That is the only thing you need to do if you want to create a unary function. All right. So this is the advantage of studying about these things before you deep dive into the STL concepts, because you can now understand that how much leverage you might have got if you are free to understand these concepts and if you are free to use these concepts, right? You are free to use these concepts once you know these concepts. Without knowing, you will not be able to use them. And these are really small things, but they are really useful to write a good code whenever you are using a template based classes, whenever you are writing your code which is based on the templates. Okay, so now let's use them. How to use it? I just need to create an object of get square, and I need to pass the arguments, type of arguments. So one is integer, the result will also be an integer. And gs, what is the name of the object? Gs. And here I'm going to write one more, int k is equal to gs, and here I'm going to pass 12, right? And when I will print this k, what should be the result? It should be 144, which is the square of 12. All right. So all set to go. So let's see what happens. Okay, you can see 144. That's it. So you are now aware that now how you can write your unary function using a standard unary function object, unary function class that has been provided in xxddef, something like that was the name of the file. Inside that it was provided. So this is the base class for all the unary functions that you want to write in your application. Okay. Okay, so now the next topic, binary function. I hope you are aware now about the unary function, and I don't need to explain any more thing. And now binary functions. Binary functions are also very simple. You don't need to do anything. You just need to, I'm just going to change the name of this function for the purpose, get product, and here rather than unary function you need to pass the binary function. And here one more argument will be there, as you might have guessed it. One type will be argument type 1, the other type can be argument type 2, and the third is the result type. Okay, so here as well you need to pass this arg2, sorry, underscore arg2 and then result. And here what you need to do, arg1 and then underscore arg2, and here I'm just going to provide the product of these two numbers, whichever I will pass here, whatever I will pass here. Okay, so let's just change the name here, get product. Again, you can see that this binary function is already available in the same class. So this is the base class for all the binary functions that you want to write in your own application. Okay, so here I'm just going to change the name of the object as well, gp, and gp is acting like a function now. So 12 into 13, or you can say 12 into 7, the output should be 84. And here I need to pass one more argument type, because first is the argument type 1, second is for argument type 2, and the third is for the result type. So 3 types I need to pass, as you can see here, for the binary functions, and then the result will come into this k. So what will be the result? 12 into 7, it will be 84. Okay, so we are all set to go. So let's see. Here you go, it's 84, right? So now you are aware that how you can write your own binary function if you want to. And you can write the functors in your application to make your code more readable, make your code more easy and understandable. But it will be understandable to only those who know about these concepts. Okay, but it's not that tough to understand these concepts. It's very easy to understand these concepts. Okay, so you can just practice it yourself and be with me, and I assure you that you will get best of the things on the Varteta learning platform. You will never get disappointed with our channel. Okay, you will get good things. Whether you are a Python lover, whether you are a C++ lover, whether you are a C lover or a .NET lover or a Java lover. Although there are very few videos as of now for the Java, but I'm going to assure you that you will get best of the things in Java as well. Okay, so we are just going to upload few Java videos as well. So till then, you keep continue with me for the other concepts. And if you are a C++ lover, then you can ask your Java friends that please like our channel videos and share the videos, and you will get more videos on Java, .NET, on anything that you can think of. Very soon we are trying to launch something around the Arduino Uno as well, the IoT things. So that will also be available to you guys. Okay, so I hope you got this video very useful for today, and you will be able to practice all these concepts by yourself, and you will be able to understand it yourself, because the lecture that you have got today, that is certainly going to help you to understand these basic core concepts before you understand about the STLs. Okay, so we will meet soon in the next video, probably tomorrow or maybe day after tomorrow. Until then, have a nice day and bye bye.